In this video, we're going to look at Unit 1, Lesson 17, which is working with rigid transformations. The lesson starts on page 167 with the warm-up. And so before you start looking at the warm-up, let's talk about what the diagram shows. So this diagram shows segment CD right here, which is the perpendicular bisector of AB. Okay, so AB is being cut up by CD. So I sometimes find it nice to actually mark up the diagram to help you. So CD is bisecting or cutting AB in two equal pieces, and it's also perpendicular, meaning you have a 90-degree angle. So go ahead and see if you can answer the four transformations. So think about it in your head. How would we take point A to point B? How would we take point B to point A? How would we take point C to D and D to C? So pause the video, write down what you think in your book, okay, and then come back to the video. So there's a lot of different ways that we could do these, okay, especially A to B and B to A because of this perpendicular bisector. So when we're talking about how could we take point A over to point B? Well, one thing we could do is translate it, right? So we could just translate it along this line segment. And so the way that we would write this out, okay, so if we were going to type this out, so I'm going to type that out, or if you were going to write this, you would say translate. You would need to say what you're translating. Okay, so I'm translating point A, and then we call it a directed line segment. So translating point A along the directed line segment, and you say the start of the segment to the end. Okay, so where are we starting at A, and where are we ending at B? Remember, it's a directed segment, so it matters, okay, what you're saying first and what you're saying second. So translate, so slide point A along the directed line segment from A to B. So that would land us there. Now, because that's a perpendicular bisector, we also actually can do a whole lot of other things as well. So we can also reflect this, okay? So we could reflect point A across the perpendicular bisector of AB, or in this case, CD. So we could just say reflect point A across line CD because we know it's the perpendicular bisector. So that would flip it, okay, exactly the same distance across. So it would just flip it over to B, so that would work as well. And then we can actually also rotate, since we know that point N is the midpoint, since it was the perpendicular bisector, we could rotate point A 180 degrees around point M, since we know it's the midpoint. So all of these will actually work to take A to B. And similarly, they'll work to take B to A as well with a couple of tweaks. So this time we're moving point B. So instead of moving point A, now we're moving point B. So we want to take B onto A. So we would translate point B on the directed segment, but this time we want to take it from B to A. So the directed segment starts at B and ends at A. And then we could just reflect point B across CD, and we could rotate B 180 degrees around point M, and that would work as well. Now, when we talk about C to D and D to C, we don't have as many options because this is the perpendicular bisector of this segment, not of CD. So we can only translate this time because we don't have the perpendicular bisector. So we can translate along the segment CD. So translate point C along the directed segment C to D. So we can do that. But we can't reflect it around, or we can't reflect over AB because C is further than D is. and we can't rotate it around point M because, again, C is further from M than D is. So then for D to C, then we just change what we're translating. Now we're moving point D, and this time it's starting at D and ending at C. So our directed segment would switch as well. All right, then in activity 2 that starts on page 167, you are going to get a set of cards, or you can just use the ones on the screen if you're just doing this as a video lesson. If you were in class and you had cards, that's fine. So what you're going to do in a card sort is you're going to separate the cards into categories, okay? So you'd have a category that each card goes into. And so you can put sets of cards in, but come up with categories of how you could separate these cards and then explain what cards go in your categories. And so just try a couple, talk to the people around you, come up with a couple categories, and then come back to the video and I'll tell you a few of the ones I came up with. All right, so I think you could come up with a lot of different things, okay? And I'm just going to give you a few ideas here. Just because I don't say yours doesn't mean yours isn't good. I just don't have time to go through every possibility. But a couple of things I've seen people do is put 3-sided figures together, 4-sided figures together, and then more than that. Okay, so then these categories would be 3 sides, 4 sides, and then more sides. So more than 4 sides. So that's one category I've seen. Another is something like this. So all of these ones up top and this one, and then this one by itself. So do you think you know what the category is? And so this one is 90-degree angles. So they have a 90-degree angle versus no 90-degree angle. So I've seen those categories before. And then the one that we're actually going to focus on here is this category. So did you have this one? Was not that. This, these 4 together, and then these 2 together. And you could have named this a couple of different things. I've seen people call it congruent shapes, okay, and not congruent, or maybe use the word equal instead of congruent. And the kind of newer language that we're talking about here is rigid versus not rigid, if we're talking transformations. So these 4 cards were rigid transformations that took them. These 2 were not rigid. So I want to focus on these rigid transformations now. And we're going to describe a sequence of rigid motions that takes one of these shapes onto its image. So first of all, how do we know that things are rigid? So remember, rigid motions means that they're exactly the same shape. Okay, so same shape, same size. Okay, or they're congruent. The image and the new, so the original shape is congruent. There's a math symbol congruent to the new. And what I want us to do now is describe a sequence of motions that will take the original shape onto the image. So remember that we know which one is the original because it just has the normal letters, right? So A, B, C versus the image has A prime, B prime, C prime on it. So this one's the original and this one's the new. So we want to be moving the original onto the new. Now you can try this. You can pause the video and try on your own. If you're in class and you actually have the cards, you could use tracing paper for that, or if it's on a worksheet that you have, you could use tracing paper. You can also try to think about it in your head. And I'm going to go over a couple different ways, or a specific way that we can do this. So go ahead, try it on your own, pause the video, and then you come back. All right, so Congruent shapes are interesting, and rigid transformations are interesting because we can follow this exact order: translate, rotate, reflect. And if shapes are congruent, this will get us to bring one shape onto the other every time. Now, we don't always have to use all three of them, okay? But if you go in this order, translate if you need to, rotate if you need to, reflect, by the time you're done doing that, the shape, the original will be on its image, okay? So you're going to see a couple of these that require all of them, one of them, or two of them. And so if we take a look here, so we're gonna move this triangle ABC onto the other one, okay? So now when two shapes are not touching, then that means you need to start with a translate to get them to touch, because a translate just moves the shape around. So right, it's just gonna grab this shape and it's gonna move it around. So we're gonna get these to be touching, okay? And so we want to translate triangle ABC by the directed line segment. So where are we starting and where are we ending? And we don't see an actual segment here, but we want to say the point that we're starting and what we want to match up. So I'm going to just pick that I want to get point A to match up with A prime. So I just named that as my directed segment. Even though it's not on here, it doesn't have to be, okay? I could draw it, but I don't need to. But there's the segment that I'm moving it on. Okay, so I'm going to take triangle ABC, and I'm going to move it on directed line segment from A to A prime. So it will move from A to A prime. So I took the whole triangle and moved it from directed line segment A to A prime, and that matched up point A and A prime. So now we can see that the triangle isn't all the way on its image. So this is now going to require us to rotate. So now we're going to rotate triangle AC. And now we're going to rotate around the point that we just got fixed together, that we just got matched up. So these two are matched, so I don't want to move them apart from each other. So now point A prime is going to be our center of rotation, okay? So you're going to stick your pencil in that if you were using tracing paper. And then we're going to rotate it, and now we don't have an amount of degrees on here, and we don't want to actually have to measure every time. So you can just say, I'm going to rotate this shape until this point lands on the other point. And so you just pick 2 points that you want to match up. So I'm going to get B to land on B prime. So I'm just going to rotate ABC until B coincides, which means lands on. So until B coincides with B prime, its image. Okay, so you're just going to take this shape and you're just going to rotate it until B lands on B prime. And then we see B on B prime there. Whoops, I just changed the size on accident. Okay, so see B on B prime. And then you can see that when we did that, C actually landed on C prime. Okay, so now all 3 vertices, A, B, and C, are on top of A prime, B prime, C prime. So we don't need to reflect because we already got the original on top of the image through just a translate and rotate. Okay, so card number 3. So now we're going to be, again, taking the original. So here's the original because it doesn't have the primes. And we're going to be moving this one onto the other one. So we're going to, now they're not touching each other, so we're going to need to get them to touch each other. So shape GHIJ, we're going to move that by the directed line segment, and now pick whichever letters you want to go together. It can literally be any of them, okay, as long as it just goes to its image. So I'm going to pick H, and I'm going to move it to H prime because that's its image. So I'm going to grab the quadrilateral, and I'm going to move it along the directed line segment that puts H to H prime. And when I did that, it actually landed the entire quadrilateral on top of all of the other points. So now all 4 points are matched up, so we don't need to do anything else. That one just moved by a translation. Card 5. So now we're going to take, and here's the image, or here's the original shape, RSTU. And again, they're not touching. So we're going to have to translate it to get it touching. So we're going to take RSTU and we're going to translate it by the directed segment. So pick which letters you want to get on top of each other. And so I'm going to match R to its image of R prime. So I'm going to grab this shape and I'm going to move R to be on top of R prime. And now I only have R matched, so we have to keep going. And now that we matched up point R, now we can rotate to get another point together. So we've got that center of rotation now. So RSTU, the point we got matched up will be the point that we'll rotate around. So we'll rotate RSTU around point R. And then you just pick what other point you want to move on top of its image, okay? Pick one that's next to it. So either do S or U. Okay, so I'm going to do S. So I'm going to rotate it until S lands on S prime. And the nice thing about this, you don't even care what direction, because you're just saying keep rotating it until S lands on, whoops, gotta get my point of rotation there. You're just saying rotate it until S lands on S prime. So if I go counterclockwise, I'm moving it until then. Or if I go clockwise, okay, so I go from here and I go clockwise, I'm just doing it until S lands on S prime. Okay, so now the direction of your rotation really doesn't matter because you're saying do it until you get there. Okay, so now we have S and S prime matched, or sorry, S and S prime matched up, as well as R and R prime. So now we've got this segment connected. So now we don't have the rest of the shape, so we still need to do a reflection. And now you can hopefully see that if we reflect, T will land on T prime and U will land on U prime. So now our last thing to do is just reflect. Oops. Reflect RSTU across the line, okay, that we just got connected. So we connected R and S, okay, so we're flipping over that line RS. And then that will bring T onto T prime and U onto U prime. This software doesn't really reflect very well, so it's hard for me to show you it reflecting over there, but you can tell T would land on T prime, U would land on U prime, and then we have the whole shape matched up. All right, then card number 6. Okay, again, we'll move this image or this original onto the image. So this time we have V, W, X, Y, Z that we're going to be moving. It's not touching the other ones. We know we're going to start with a translation. Pick any of the points that are matching that you want to get together. I'm going to go W to W prime. So I'm going to move this pentagon. Oops, and then I didn't put the letters on there, so let me redo this. So then we're going to move, so I'm going to take this pentagon and I'm going to move it so that W ends up on W prime. Now that I have those two matched up, I'm going to rotate the shape, okay, and I have them matched at W, right? So that's going to be my center of rotation. It's going to be at W, W prime. And now I'm going to rotate until, and pick either X or V, the ones next to W. So I'm going to do until V lands on V prime. So if you're doing tracing paper, then you'd stick your pencil right at W to make sure that that sticks. And then you're just going to rotate until V lands on V prime. And then we would stop and we can see that the whole shape then landed on its edge. So we have no need to do a reflection in that case. So as you can see, if you translate, rotate, reflect, it's going to get each of these shapes onto its image. And that will work every single time. Okay, now sometimes you can see other things happening, which is what Diego saw. So Diego looked at this trapezoid here, and Diego said, you know what, I can tell that this is a reflection. Okay, but when we talk about a reflection, we need to know the line we're reflecting over. And Diego said, but I don't know where the line is, so I'm just going to guess. Okay, well, guessing isn't a great option. Okay, so first of all, how does he know that it's a reflection? And one way you can tell the reflection is based on the direction that the letters go. So when I look at this, R, and I go in clockwise order, I see R, S, T, U, and that goes in a clockwise direction to go R, S, T, U. So now if I look at this one and I start at R, S, T, U, V goes in a counterclockwise direction. So when they flip directions that the letters are going, that tells you that there was a reflection. Okay, so it switches from clockwise to counterclockwise. That's an indicator that there was a reflection that happened. So now, instead of Diego having to guess where the line of reflection is, how could he actually find the exact line of reflection? And this goes back to the idea that you can reflect over the perpendicular bisector of an image and its original, okay? So we need to construct the perpendicular bisector of any OG to new segment. So by connecting an original point to its image, that will give us a segment that we can construct the perpendicular bisector of. So I'm going to do it of SS prime just because it's kind of off out here where like back here there's all sorts of, the trapezoid gets in the way, so this is kind of off to the edge. And so we could go ahead and construct the perpendicular bisector here using a compass. So perpendicular bisector of S prime. You could do T prime, R prime, U prime. But I'm just going to do it of S prime. So then draw a circle around S that goes through S prime, move it over to S prime, draw another circle, and then connect those intersections, and that will be your perpendicular bisector. Okay, so then that purple line is your perpendicular bisector. And so then that is your line of reflection. So there's your line of reflection. Because we know that this cuts this in half, and then it also is a 90-degree angle. So by definition, okay, S is this far from the line of reflection, and then S prime is the same distance, and we know distance at a 90-degree angle, and we know that those two distances are the same. So by definition, that is a reflection. So sometimes you can see other ones. If you just want, you know, a set path to get there, you can always translate, rotate, reflect. Sometimes you might be able to see some other things, and then you could say reflect or the perpendicular bisector of SS prime. Okay, or you could construct it and show exactly where it is. All right, so let's take a look at this lesson synthesis and see if you understand what you just did. So do you know how to figure out which is the original triangle and which is the image? So remember, the original has those non-primes, okay, so it just has regular letters. And then the new or the image has those primes. So you see C prime, A prime, B prime. And then what sequence of transformations would take ABC onto A prime, B prime, C prime? So let's see if we would need a reflection here. We know we need a translation because they're not touching. We can see we'd also need to rotate it. So let's decide, let's look at it and see, is there a reflection that's going to be necessary? So when I look at ABC, when I'm doing this, it's going in a counterclockwise rotation. And when I look here, ABC is also going in a counterclockwise rotation. So they're both going counterclockwise, which means there's no reflection. So we're just going to need to translate and then rotate. And now this is not precise, so I'm just saying what we would need to do if we needed to actually describe it precisely. We would do that, but I'm not going to do that right now, okay? And then would that sequence work for just one pair of congruent triangles, or would it work for others? And it would work for a lot of them, right? So it would work for any of them as long as there isn't a reflection, okay? If there's a reflection, then we would need to add in a reflect. So if we look at this set, what's different about this and the last one? So if we look at the order here, ABC, this is going clockwise. ABC here is going counterclockwise. So this one has a reflection. Okay, so for this one, now you can translate, rotate, reflect. That's going to work every single time, right? So you can translate, you can rotate, and then you can reflect. Okay, or you can say reflect over the perpendicular bisector of CC prime or BB prime. So you could say it like that instead of writing everything out. Okay, and that's actually true on this one too. You could just rotate here. Okay, and we could just rotate by using the midpoint of an image and its original. Okay, so you could say rotate around the midpoint of AA prime until C lands on C prime or whatever. So you could say rotate triangle ABC around the midpoint of AA prime until A lands on A prime, and then that would take you there directly as well. So if you can see that, that's fine. Otherwise, just follow the translate, rotate, reflect, and that will work every time as well. So hopefully you can describe transformations that take given points to other sets of points, and then you can work on the practice problems for this lesson. I think all of them are good. You could skip number 8. Okay, if you want to skip number 8, that's fine. And then here's a cool down that you can use to see if you understand, and if you're not quite sure, then you should talk to your teacher.